Hello, and today we are going to be talking about what this term WAP means. W-A-P. Do you know what WAP means? WAP means water added pressure. Okay, so this is going to be a lesson on how to calculate pressure for liquids. There are two main rules to calculating WAP. The first one is you have to understand that the pressure increases as you go down from the surface. So basically we start from the top and then we add pressure as we drop. And that is actually what this equation here is talking about. So the pressure here is the added pressure due to being underwater. This is your density, your gravitational field strength, and then this H, right? This is the one you have to be careful of. So always remember, you start from the top and then you drop, right? And so the further you drop, the more pressure there is, as shown in my drawing here. If you are close to the surface, H is a small value and you have a small amount of pressure pushing in on your object. And if you are further down, then this H is a larger value, and so you have more added pressure due to being underwater. The second rule for calculating liquid pressure is this one. It's very simple. For any 2 points, right, as long as they are at the same level in the same liquid, then there must be a same total pressure. So this is very useful for us to form some mini equations. So let's look at these 2 points, point A and point B respectively. At point A, it's at the surface of this mercury. So the pressure here, right, is just whatever is directly above it, which in this case is atmospheric pressure. Pressure A is actually equals to the atmospheric pressure. Okay, and then pressure B, where is the pressure coming from? We can look from the top, make it drop. Okay, so the top pressure here, this is a vacuum. P equals to 0 in a vacuum, because vacuum means there's no air or anything to exert pressure at all. So 0 pressure at the top, but we add the mercury pressure as we go below. So pressure at B will be equal to 0 plus rho times G times this H. H in this case will be 760 mm. Okay? So now, according to this rule number 2, which says that as long as we are in the same level, in the same liquid, same total pressure, so then that means this atmospheric pressure must be equal to this rho GH, right? So you can combine these two into a single equation like this. Rho GH equals to atmospheric pressure. And this is the method that we will use to solve maybe like 80% of the pressure questions at O level. Let me show you now how to use these two rules that we just learned and apply it to some questions. Now, if you want to try it out yourself, go ahead and pause the video here and try it out yourself first. If not, then let me show you what's going on here. So the diagram shows us that there are two upside down inverted glass tubes in a bath of mercury, and one of them is has risen to a height of 77 cm. The other one is only up to 60 cm. Now we are told that this space up here is totally empty. In other words, it's a vacuum. All right. Every time the question tells you that something is a vacuum, it means that there is no pressure inside here. Okay. So that means at the top of the mercury here, this pressure is 0. Now, we are trying to figure out what is the pressure inside this trapped air space here, right? So let's call this PQ equals to what, question mark. Okay, so how we do this is, well, remember the two rules. Second rule is that 2 points, as long as they are same level in the same liquid, they must be at the same pressure. So what I can do is, if I draw a horizontal line across here, right, this point here and this point here, same level, in the same liquid, mercury, they must be at the same total pressure. Okay, so what we do first is we can write out the mini equations for the pressure at each of these points. Now, how do we do that? Well, we apply the first rule, which is the one about the WAP, right? From the top, make it drop. So over here, this is actually at the surface of the mercury. So this pressure here is just going to be PQ. Okay, and how about this point here? Now this point is, if you do a little bit of math, right, this is just 16 cm below the surface here. So surface is 0 pressure, and then you drop, and then 16 cm, right? So pressure at this point would be 0 plus rho times G times 16 cm. Okay, now what is rho and what is G? Rho is the density which is this amount. G is the gravitational field strength, which is this amount. By the way, if you are confused about what I mean by this rho, what I'm pronouncing is actually RHO. Okay, this is a Greek alphabet. In your phone, it looks a little bit like a P, but with a curly thing like that. Okay, usually we use it to denote density. Okay, now back to this question. Since we know that these 2 points, same level, same liquid, same pressure, so therefore we can equate this to this side, right? And let's write that out. PQ equals to 0 plus 13600 times 10 times 0.16. Okay, then we just need to calculate this to get the final answer, which is 21760 pascals. Right, rounded off to 3 SF, that would be 21800 pascals. Okay, moving on to the second example. Let's have a look at how we can solve using the two concepts that we've learned earlier on. Now, again, if you want to try it out on your own, please pause the video first. If not, then here goes. So this question, we have a U-shaped tube with water filled up like this, and then we added some amount of oil on the right-hand side here. And then we allow this tube to reach equilibrium, and then it stabilizes like shown in the diagram. So we are supposed to find what is the density of this oil that has been added on the right-hand side. And how we can do so is, again, by first identifying 2 points, and I'm going to identify them here and here, right? For the purposes of utilizing the same level, same liquid, same pressure concept. And what we can do from here on is we can write out mini equations to represent the pressure at these individual points. How are we going to do so? Well, we are going to use the WAP principle. So from the top, and then we add the pressure as we drop. So the top pressure, what we have here, atmospheric pressure, right? And then as we drop, we have to add the oil pressure. So mini equation for pressure at this point would be atmospheric pressure plus rho, which is density of oil, times G times H. Now H in this case, you can see it's 10 cm, 0.10 meters. And then let's do the same, write out a mini equation for this point. So again, using the WAP idea, we have atmospheric pressure at the top, and then we add water pressure as we go further down. So pressure here would be atmospheric pressure plus rho of water times G times H. And H in this case would be 8 cm. Okay? Water, by the way, take note that the density, right, 1.0 gram per cm cube, you will have to do a bit of conversion to find that it is 1000 kg per meter cube, right? If you're unsure, always convert to SI units. Okay, now these 2 points, remember, same level, same liquid, right? This one is touching water, this one is also touching the same water. So they must have the same pressure. So that means, right, this mini equation here, the pressure here, must be equal to this pressure here. Okay, so then we can equate it out. P atm plus rho of water times G times H equals to P atmosphere plus rho of oil times G times H. You can see here that atmospheric pressure appears on both sides, so both these terms will cancel out, and then you're just left with a rho GH equals to rho GH form of equation, which then means that you can start to cancel out common factors. For example, G cancels out. Okay, so once you have cancelled out this, we can just rearrange it to make our unknown density of oil the subject, and our final answer will be calculated as density of water multiplied by the height of the water divided by the height of the oil. Height of water is 8 cm, oil is 10, and water density is 1000. So doing a bit of calculation, you can get the final answer 800 kg per meter cube. Okay, so I hope that was helpful for you. Two very easy rules to remember. From the top, add as you drop, and then second one is same level, same liquid means same total pressure, and then you can use that to form mini equations which you can then combine to solve your pressure equation. Okay, thank you for watching up to this point, and see you in the next video.